Greetings to all the dignitaries, Dr. Manoj Khanna, Dr. Indramani, Dr. Gajendra Singh, Dr. Alagasundram. I would like to first thank Dr. Smile, and again, I would like to talk about a story how I met Dr. Smile. So before that, of course, Vijay, whom I met. So I was working in my past industry, and and then one of the project we were working was Tier 4 for the US, and that's how I came to know more knowledge about the Tier 4 technology. And Vijay was part of my team, and we worked together. Later on, I was given a responsibility of defining the precision agricultural technology for the company. And when I started working, I started interacting with Vijay. And Vijay then gave me a hint that I need to talk to Dr. Smile, because he did some work in the past of making the tractor smart. So I connected with him, and yes, when I talked, as usual, I got some repulsion. He was not very happy, and he scolded me. Why don't you provide CAN in the tractors? I've been talking to industry for so many years. I said, that was a little bit of a shock for me because I thought maybe the industry knows the technologies, but beyond industry, there is a gap because for me, the technology was already coming. And I told doctor, it's already coming, so don't worry. Can we talk more than that? And that's how probably we kept on exchanging dialogues between us. And then he probably felt I'm worth talking over here and included me in team. And we have been talking since many years, means since at least 1 year over there. I also thank, Dr. Gajendra. Very happy to see you. You remember were kind enough to give me opportunity to drive you once. Of course, in one direction, second direction, I couldn't drive. You know the reason. So that was Vijay who drove. So thank you very much. So that was a very nice event. So I'll be talking about what is happening in industry. So I talked about Tier 4, but I also worked in Tier 6 technologies then. And when I talk tractors with my past background of experience, of about 20, 21 years in tractor design and development, both for domestic and export market, I learned many of these and I came in contact with many of the agriculture engineers. And this was my realization that there are challenges. And I think Dr. Indramani rightly said that, some of those and Dr. Ismail also, made it very simple to say that, we talk about it. And during my, research on agricultural technologies and precision agriculture, when I started reading, topics, I realized I really want to connect with the topic. I need to know many of those electronic and communication, components. So I went little further. I had another one. I had another. So then I talked to doctor. We have been talking. Why don't we make as a so? Thank you, doctor, for putting this webinar. I think this will be really very useful going forward. So when I talk about tractor, actually, also an ag machinery, and when it is happening, what basically is happening, the tractor itself is becoming a communication and automation equipment. And that's what I will tell. And that's where what I realized that the ag engineers, at least at the education level, are not knowing it. It was not happening in the past, but in industry, it is happening very fast. And there is an event which is trying to make it happen. So next page, please. So it's a storyline of, yes, 70 years plus ag machinery and mechanization has been one of the key mainstay or growth of the agriculture in India. So far from 2000, the tier emissions started in tractors and it continued. I think Supreme Court pumped in, pushed in. It was continued delaying, but then it made mandatory and it started happening. So tier 1 happened, tier 2 happened, tier 3 happened. These are basically emission levels and it becomes more and more stricter. And in India, we call it TREM. This is basically TREM, but there are some changes made with respect to India, and it's called TREM 3, TREM. So up to TREM 3, I'll say TREM 2 was fully mechanical. I think we should thank all the engineers who worked on it to say that because there is a cost engaged in that. And they said, okay, up to tier 3 also, there was a very, very limited electronics over there. So before that, when I say mechanical, it was mechanical and electrical tractor there. So for 70 years, I also compliment all the agriculture. They probably mastered this, this machinery a lot. both tractors and ag machinery to take the best out of it. But the demand for the customers continue increasing. It doesn't change. Fuel efficiency chahiye. All 20 years I kept on working along with ag engineers and the mechanical and engine engineers to keep improving it. But we wanted to make electronics, and I think the electronics and engine came almost 10 years before. All the industry started trying it. But when it comes to fundamental of introducing in a market, there was some repulsion, and I'll talk later. But from 2020 onwards, things are changing. This is the government's commitment to WTO that we will go for a clean environment and the technologies will change. And in the automotive industry, this has already happened. Tier 6 is already implemented. For tractor industry, Tier 6, Tier 4 will get introduced from October 2020 for 50 horsepower plus. And Tier 6, it's going directly jumping to Tier 6 by 2024 as per the current thought process. So while you do that, you make the storyline is you make the engine, and Dr. Smile talked about it, to convert into a communicating engine. And alone, a communicating engine does not provide a full benefit. And this is an industry scenario I'm talking about. They would like to put it on a tractor to take all the benefits of making the whole tractor as a communicating. And from there, it continues, the journey continues, And it's like communicating systems. Then you have got cloud already being talked. Doctor also talked about so much, and AI and ML, and then edge computing algorithm. And now the time is not left over much. If you look at 70 years, you could spend time, and then 5 to 10 years left over. We are talking 2024, probably, yes, tractors will convert, but the systems will lag, but it's not far. Should the agricultural engineer not change and start looking at, as expressed by Dr. Indramani, as expressed by also Dr. Alagasundram, and also by Dr. Smile, it's same. Actually, we need to do it. So next page, please. So this is just some of the information that when it is changing, there will be always some changes depending on the scenario, and we do not know how pandemic is going to affect at this moment, but these are sacrosanct at this moment, the dates. And what you see is we are talking about basically particulate measure, the oxides of nitrogen, the carbon monoxides, the hydrocarbons, the particulate matters. Next page, please. How and why this is so complicated? You think about Tier 0 where there was nothing, and this is of course the slide taken from one of the John Deere's. This is for showing. Okay, and this is public available information over there. If we take two axes of particulate measure and oxides of nitrogen, and you go from Tier 1 to Tier 6, and it has happened in the last 20 years, or 25 years it will happen, you see a dot in the 6th year. This is not possible without introducing a lot of technologies in that. And what is interesting is what you see is particulate measure and NOx, they behave opposite to each other. You control NOx, particulate measure will increase. You can control NOx by reducing the temperature of complete system, but the fuel will not burn. You want to burn fuel, you increase the temperature, NOx increases. And you're talking about a machinery that is in the agricultural system, and everybody of you know how much an agricultural machinery gets loaded in a different manner in different applications, a huge amount of applications. So, and all this now, when this Tier 6 or Tier 4 regulation comes, this is on a real-time basis and a transient mode, which means you have to really optimize all the points which is required. And one knows Volkswagen issue or General Motor issue in the past, there were certain leeways were there whereby in practical scenario, people could play with the fuel efficiency a little more and play with the emissions, but they paid for it. So all those have been clamped. So now this is really, you need, so there are on a real-time basis, the ignition is happening in a engine, chamber, and it's emitting something, it goes. There are sensors, there are temperature sensors, NOx sensors, hydrocarbon sensors, and they sense and they are sending the information back to something called as ECU, and that's at a high speed processor over there. It has been given a program to understand it, and then it releases based on the processing, it will release a decision and going back to again the engine saying, okay, you try to put so much fuel or so much air is required. So it's a very, very complex scenario. It's so complex that a development of this takes something like 5 years. When I say 5 years, it consists of initially defining it, and during that time, anytime you change any of your components, everything starts changing. You develop an engine, you first then put it on a tractor, then you run a tractor, go for application, then you send it to actually the customer to understand that he is undergoing through all the scenarios and unearthing. So there are so many bugs developed, and it's only after that. So that is why, so there was two reasons the industry started putting. One is this, they knew this is coming. So after 10 years before, so they started putting it. Second, it was of course an innovation brand over there. And third, probably they thought it can give quite a bit of advantage. Next slide, please. Setu, next slide, please. So here you see the top blue one is a very simple engine, and it is on a tractor which is having nothing, a cut section there. It's a mechanically governed, and I think engineers have done a wonderful job. They have tried to optimize it so much with, I think this is very popular is of course Bosch in this. They have really done very well. Mechanical fuel pump, and mechanical control, simple electric wirings, no or very limited sensors. If there were some sensors, they was to only measure temperature and show it on a screen, or a gauge there, otherwise not. Do something like what you see is so many after treatment devices, a huge engine it becomes, for the same one. And when you put it on a tractor in the right hand side bottom, if you see, where is an engine? So what are the things? So you have to use a high pressure, electronic pump. You have to use electronic engine governing, high pressure common rail systems there, exhaust gas recirculation, which is cooled. There also you need a lot of sensors and automation over there. Turbocharger with intercooler, again sensors and programming softwares to understand it correctly. After treatment devices, they are innumerable programs. So there's a diesel oxidation catalyst, there is sequential catalytic reactor, there's a diesel particulate filter, advanced air management, engine control. So there are many more. But when I talk about all these things here, if I had to do with an electronics, so only with the electrical, that means you are connecting one wire to another wire, one sensor to, it would have been just a mess. And that's where the scan system, what Dr. Ismail talked about, came, So communication protocols. And I will talk very briefly, and Doctor will cover later. But so CAN became important. So once CAN became important, so can you have a next slide, please? This is also sort of a components what you see here. So you see diesel oxidation catalyst, EGR and all that. There is an ECU there. And depending on the horsepower levels, the things can become more and more complex, and it can go to something like requiring the urea system. And believe it, it really takes a lot of time to optimize this and get all the results in all the condition, with a caveat that you have to be fuel efficient and you have to be cost effective. All these go contrary, but people are managing. But can we have a next slide, please? Setu. So the control area network can I talk about very brief, so this is what a wiring harness will look like, and and on the other side, when you have a CAN, you see what it is. So interesting part is it's all, all the devices, there is only a single bus, and everybody is actually sending their own messages. So messages are available and if it is relevant, you work. It's like if there is a switch which is belonging to switch on the bulb, when you push it, it will send this message. Everybody can see. That's not relevant for them, but the bulb will see and it recognizes and takes it and works on it. So it's also can be equivalent to something like you have got a on the air, you have got so many, channels of TV or your, unless only when it tunes, the frequency matches and you can hear it. Very similar over here. So, yeah, next slide, please. So this becomes really low cost. So in the past, electronic engine was possible. It was not possible. And I challenged the team in industry saying that we will introduce CAN, and that project was on, and there was a cost. And we said there's no cost because so much wiring harness you take out, and it really, really becomes very, very useful to have this. It's very robust. It's very efficient, and robust when we say there are so many interferences that happen that it can take care. It's very flexible because you can add any amount of nodes because all the messages are there. Another node you add, its message will be there, it can be picked out. So it's really, I'll say it's like a boon for a scenario which we are looking for. It makes the whole system communicative, and that's what Dr. Ismail was fighting for, and it was not happening. Yeah, please, next slide, please. So question comes is, when there was, people think it was so much of advantage, right? So this is electronic engine is costly, whatever I talked about, it comes like 25 to 40% costly. And it's complex. Whenever industry 10 years before wanted to go, nobody accepted it. Their own departments, marketing departments, the customer, the service department, it's a complex technology. There is a fear. There's a software and all that. Reliability, always people worried about the, electrical reliability was one of the big problem. Industry has done a wonderful job of saying that reliability is taken care. But now electronics reliability is another one where people feared the lack of skill and eco-infrastructure. When I talk about eco-infrastructure, it actually does not mean the architecture of a tractor alone or a system there. It also means, how you diagnose the whole thing, how, it can be, going to the service industry, the production industry. So all that matters, all of them have to change. And it's not that simple over there. So you converted first in a step is an electronic engine. So all this was a push from the industry side, and it was not happening. So now the event is making it free for you. And the huge advantage, which I'll show you later, it's available. Next slide, please. So the high cost of the engine could not justify the performance it could achieve. So there were many attempts made to provide different mode with engine alone, making it electronic, and saying that we can make it efficient, and it never happened to that level as was expected from its cost, and never got accepted. But because it was communicative, so you could see something on your smartphone or something on your computer screen, you could diagnose it. So there were those things that happened. So, but it was not worth. So industry made attempts, but could not popularize this. While the ag industry in general was converting it to some of the smartness like IoTs in the precision agriculture and all that, the industry was waiting. But now that tipping point has happened. So people then would like to put that into a tractor. And the only way to make a best advantage of tractor and implement is to connect it with a CAN and make the whole system as a CAN system. And that's where you say it, that now you have got a system which is possible to do many more things. It becomes, you provide a router, you can start talking to cloud and internet, and it can do all the wonders. So it can give a decision. For example, if your tires is slipping, you will get an intimation from the GIS saying that tire is slipping. So you need to lift so you have electrohydraulics, you have to lift the implement, simple, So those wonders are possible. Go to the next slide, please. So now I say that, okay, we change our tone. Of course, it is getting now almost pulled. This will be available. The cost is high, I agree. It will increase the tractor cost to 15 to 30%, which means 5 lakh tractor will cost 6 lakh 50,000. So if you go there, I'm sure you will repel it. But if I say in some of the application or many of the application, you fine tune the total application together with the engine, because now engine and your implements, everything can talk together. You can improve the efficiency, and with 1,000 to 2,000 hours of an engine in a year, or a tractor in a year, you know how much you can save. It can go into lakh. When you go now and tell you can save more, and every year you will save, whole game will change. Of course, there are other things. Consider complexity. I think that's where we should thank Dr. Ismail for taking this baby step. I'm sure it will go a long way with your help. Reliability, it's already proven. It's already tier 6. It's implemented there, and people have learned. And there are organizations, industries there which have both the capabilities. They're already introduced this from the automotive side, and they know this technology, and they have mastered this. So it is very easy. So this is proven automotive, lack of skill. Automotive has already provided that ecosystem. Everybody understands it. Service has got diagnostics systems. Your tools are there, computers are there. All this changes, So that is available now. So we are talking about ag machinery now as a system. So you can take a huge benefit. Next slide, please. So this is where the whole, now you have a tractor. So there will be, this is of course Kubota's, I've taken it. And what you see over here, and that matches with my philosophy. That's how I took it over here. So your tractor becomes, auto steering is becoming, so you now are communicating with your satellites, and that's giving you a location and how to move straight. Similarly, it is communicating with all other machines are communicating. So that's how what it happens there. You have got now the next level which will come, which is you have more systems which is attached. You have a cloud, data sharing, data science, everything is happening, and multiple machines can run together, communicate with each other, and help each other. Level 3 already talked. It's the unmanned operation, which is the robotics, which is coming. Robotics, a tractor. Now people are talking about tractor. Nobody's sitting there and moving and doing all the job. So next slide, please. So one single event. So it has already happened in the global world. It was not happening in India world. And one single event is going to change this. So this is an approach which can from individual component, tractor implements to smart products to your, something which is complete ecosystem farm 4.0 I'm talking about, So now the tractor communicates with all other ecosystem in and around the farm system, Next slide, please. So now you add further. Now you say that you already provided the cost back and still providing. You make your communication savvy, automation is possible, AI ML is possible, and farm productivity. So it can contribute to that, farm business and management, farm to fork, complete ecosystem. It can really connect with the, let's say, trolley, if you make that smart, and really call the trolley, and which is happening, and that I am available. I have completed my harvest. Can you come and collect, And that's what will be happening.
Robesh, yep. You have another 2-3 minutes.
Okay, please. Next slide, please. So we are talking about, so please change the slide. Next slide, please. So this is new. And that I have not put any, of course, patent on this. This is new that, of course, when you go for a cloud service, one of the biggest challenge, and we can further talk about it, is that connectivity. Farm, villages connectivity is poor. And what I'm saying is, if you can upgrade your tractor to edge computing, you have to have an edge computer there, and then the tractor is going into the field, and whatever cloud communication you were thinking, because cloud, one is connectivity, another is latency. So it takes its own time to do calculation and send it back then. For now, the tractor will be available. It's edge computing is possible. It has all the intelligence required. There are IoTs in the system, and they can talk, and you can provide all the intelligence. So throughout the day, it collects all the information, comes back, and whenever it comes back to the base station, it will find internet and get connected. So next slide, please. So it's your profession is changing. So agriculture engineer, this is the message there. Your profession transformation is already, and it's not now 70 years. It's now few years. So that has started. So next slide, please. And this is my last slide. So earlier you connected with agronomist, agriculture scientist, electrical engineer, maybe engineer, mechanical engineer, and you really perfected the mechanical machine, and you were the center of it, which provided us best solution to it. But things are now being pushed. What it matters is you know the applications. You are the integrator. If you understand the what is coming and you want to take an advantage. If you don't, then you will probably not be able to operate this same tractor efficiently or take it for advantage. It's there. And when the development is happening, can you contribute directly to them because they are looking at artificial intelligence and all that? So yeah, please click on. And no, back, please. So I am, challenging that. Are you ready for this interesting journey? And it's there, and that's where the Dr. Ismail's point was there, and also Dr. Indramani said, it's something which we have to learn. We are not going to make masters, but if you know this, you connect with all of them, which is blue here, and the purple, in a very well scenario. So thank you very much.
Thank you, Robesh. I think I'm going to strip him down in the talk because typical presentation we have. I had like a typical presentation where we go for meetings and seminars. Let me analyze it and see. And because this is a webinar for us to fight each other and to come to the correct conclusion what is right. Okay, I will talk about some of the topics. What he talked about, canvas. There is nothing but two wires. Just two wires we are talking to connect. And the two wires gives what information? It's the engine RPM, fuel consumption, that means fuel efficiency. You know how much the engine load it takes. This I'm fighting for so many years because I used it long back. We are talking 25 years back it was designed. And Bosch has made the CAN first standard. They're nothing but two wires communication, that's all. And they made million money. And the question of patenting is very important, you see. For example, he told about fuel pump. I know Bosch, they made fuel pump a patent. That's where they look for it, small things. We are missing the boat because the CAN was very useful for us. For example, rototiller, they want to control. Rototiller is very difficult. With the canvas becomes life very easy. Because how will I find out really what is the RPM engine is working? And how do I have to adjust RPM of rototiller with the forward speed? Otherwise, I cannot do it. A simple example, rototiller, forget about sprayers and all. The industry, could have costed him only 700, 800 rupees to provide the canvas. But they were not willing. This I'm telling in public, they are not willing. This question is, now they are coming, I'm very happy because it will change. Now, this J1939 protocol is been used already by, let's say 5 years back, somebody in Brazil asked me, can you write the protocol for the tractors to come with the J1939? Because most of them proprietary, but Indian manufacturers were not coming. Now they have to come but now the scenario, according to me, is going to change in the tractor. He told about small tractors are going to come to India probably because the robots and small tractors probably, in my opinion, has the more need in India because we use still 70% of tractors for transportation. We tested on heart and see transporting tractors is not the best. We have better vehicles we can use for transportation. That's a different argument. We'll come back to the second one is about now this Robesh talked about edge computing and words like this. This we all use as a presenter. We tell edge computing, we tell cloud computing. We don't give example. Your Alexa is edge computing, for example, or Google, hi Google is edge computing. Give me an example what edge computing can be used in agriculture straight away to see. That is a bit difficult now because we don't understand. So our objective to see what is edge computing in simple terms that everybody can understand. Can use it in a small one. No need to go for very complex systems. That is what I want the objective of this webinar to come, to explain the basic principles. So everybody's mind started flowering, blooming, and telling, I can do it. It's so simple. Why the hell why I cannot tell the guy to do this job? Because very simple, starting from sensors, actuators, starting from solenoid valves which are used in agriculture purpose. There's no manufacturer in India who may manufacture solenoid valves in agriculture. So how the drip irrigation will come? Really, what's the price they are giving? You just, any agriculture engineer strips out and see. So there are thrust areas which can help the farmers. We want to, actually the objective will come. Now, I have two more people, expert people, to talk about, I want the experience because I am very young. I have much more senior people whom I have to learn, and I believe in learning, and I want to pass on to the youngsters. But I'm, like I told, my guru is sitting there, so he taught me to be straightforward and say, I make mistakes, a lot of mistakes, I agree. But I think our objective is my duty is to pass on what I gained, the life from him. He was one of the person who was very, very important for my life. Now, Dr. C.R. Mehta, I remember 4 days back, I told I want to make a seminar, webinar like this 4 or 5 days back. He was very happy. Okay, this is I told Vijay to talk to him, and then I want C.R. Mehta to give the comments, because I want to remember some people who worked on it for a long time, ages, and whether their opinion is it required for our regular engineers to get exposure to learn into electronics a little bit. See, because we say that fellow will do electronics fellow. They don't understand that much. Why don't we give a little bit importance? I think we should. And C.R. Mehta also was very keen on that last time when I met twice. He was telling his assistants that you talk to him what technology we can improve and how to do it. So I would like now request Dr. C.R. Mehta to give a few words, please. Setu, can you put C.R. Mehta is there, no? Dr. C.R. Mehta, can you please enable Setu?
Mehta is not present, sir.
Is not there?
No.
Okay. Are you sure? Dr. Okay.
I haven't seen his name.
Okay, he was there. Okay, now next another one important person I should like to invite is Dr. R.T. Patel, because we would like to learn from you your opinion on how we can do it. Whether this is required, how we can continue. What are your suggestions, please? Dr. R.T. Patel, can you enable it? Setu?
Dr. Patel has left, I guess.
I will ask him to connect again.
Yes, sir.
Dr. Ismail, can you hear me?
Yes. Yeah, I can hear.
This is Alagusundaram.
Yeah.
Yeah, would you mind if I take 1 minute? Because
of course,
all of you, Dr. Singh sir, and others, please excuse me, because I have set up another meeting at 8 o'clock with some other activity. So which means I may have to leave in another 5 minutes time maximum. So I like to, based on the last 1.5+ hours of hearing these lectures, I have some suggestions to make to the organizers. Would you mind if I tell that?
Absolutely, you have to tell.
Thank you very much. Last week we had a Zoom meeting with all our directors and DG here in ICAR, and we have had about 148 connections at the same time. And all the 148 connections, we had the video of everybody going on the screen. But today I'm finding that only the speakers are going on the screen. But many people do not know each other, and it would be a good idea you correct that part of it so everybody's video goes on the screen and everybody sees. It is also a connection with each other. Networking is also very important in these activities.
Very important.
So that is one of the things I am observing. And Dr. Ismail, you have been very wonderful in organizing this, but we must introduce the speaker where he is coming from, like Robesh Maity. I'm hearing for the first time. You're a wonderful speaker and the presentation was good. I would have, liked to know your background before you started speaking. Then I could have connected more easily. And that was missing in that. And Ismail Saab and Indramani Saab, as well as Vijay Singh sir, if there is a possibility for providing some reading materials on soft copy to the participants, it would be very nice, so that they have some record for doing for the future. And applications are something we need to go about, because we in ICAR, including DG, in all our meetings, we are talking about apply electronics, apply artificial intelligence, apply this, apply. We are talking about that. So basics is very important. Application is, and even Syed Ismail Sab told that there is no moisture measurement device in India. And I told in the very first visit to CIAU Bhopal 5.5 years ago, they have a precision fertilizer applicator. I told them it is fine. First you are taking the sample, putting into the computer the results of the sample, then you are asking the machine to move forward. Create a methodology to measure the soil moisture on the go. and still we could not do that. And maybe that type of things we need to think very seriously. And what I have listed some of the soil moisture measurement, autonomous vehicles. Mr. Dr. Maity also spoke about it, and drones in agriculture. Myself and Dr. Indramani are working on it for making some guidelines for the country. And machine learning, artificial intelligence, irrigation automation, and input use efficiency is one of the major topics we are talking about too much in ICAR. And more importantly, wetland automation. The most difficult activity of any agriculture operation is wetland operation. And we have funded a project in TNAU where they are working, Dr. Divagar Dureraj and Dr. Manohar Jasdas. Dr. Ismail will know them very well. They are basically working on developing a direct seeder for wetland. They have developed a toy-like unit now already. This toy will move automatically inside the wetland field, sow the seeds. Man need not go. And this toy need to be made into a prototype machine. And we are working on it. And many operations in wetland are the most tedious operations. As you said, we had crop cultivation in our second year of undergraduate education. Going into the field was a nightmare because of those, insects inside, sucking our blood. So somebody can work on that area. Dr. G. Singh has worked a lot when he was in AIT and others. So that is an area. Automation is important, but wetland automation I found more important than garden land and other areas. These are some of my basic suggestions based on my observation in the last 1.5 hours. If I went a little bit overboard, please don't mistake me. And I will be happy to come back to meet all of you everyday basis, 6 o'clock in the evening. And it's a wonderful meeting with all of you. If you kindly, please excuse me, because I set up the other meeting at 8 o'clock. I have to get ready for that. Thank you so much, all of you.
Thank you.
Thank you.
Yeah.
Thank you.
Yeah.
Thank you, all of you.
Patel is here.
It was a good suggestion. I think first I apologize for arranging in very short time.
I have noted down the points which has been
Yes.
suggested by DDG. So
Yeah, we will. Yeah,
we will take care definitely.
we will take care of that point. All is discussed. So I apologize again for not possible this video. But then there were restrictions. We are thinking about whether to use this particular application or not, and security issues which came from Ministry of MHA we got. So we went through all those things. So now this 100% sure it is secure at least. But then we have to give some leeway. But we'll correct it by tomorrow. Now coming back to this, I think Dr. R.T. Patel has joined. I would like Dr. R.T. Patel to give a few minutes of his opinion, please.
Yeah, thank you very much. I think, am I audible?
Yes.
Yes.
Okay, yeah. Thank you very much. It is a wonderful initiative. In fact, we need automation in agriculture in the various branches, right from irrigation to food processing everywhere. And there is a lot of trained manpower in this field in the specialized engineering disciplines. I think what I feel that we should reach out to them. In fact, ag engineer learning everything related to electronics. For some people it is possible, but most of them it may not be. I will tell you my experience. I have an NGO through which we thought that we need to have a moisture meter or a sensor so that we can find out the moisture content in the sacks itself when they are brought into the mandis. And then I put it as a appeal to on my Facebook that whoever is interested can contact us if they want to work on it. And there was a team from Manit, when Professor Lalita Gupta, she came forward and said, sir, yes, we can work on it. Of course, we did not have much of the amount and we gave only 40,000 rupees as a funding. And with her students, she came out with that equipment. It was a prototype, of course. And then later on, maybe that engineering college will take it up for commercialization. But similar to this, whatever our problems are there, if we can flash it to the electronics engineers in different engineering colleges around the country, we will get wonderful ideas from the youngsters and get solutions to it. Of course, for very critical points like tractors and all those things, they may not be coming forward, but the small solutions. There are many problems in the field which require the smaller solutions, electronically also, and also other mechanically. And if we take them along with us, I think we will have solutions to them much earlier than what we expect. With this, I again compliment ISAE for doing this, and they should be keep on doing it for different disciplines in future also. Thank you so much.
Thank you, Dr. Patel. Now, I think we are back to discuss about, I think Sir Mehta still not joined, according to me. Okay, now I think I would like Dr. Gajendra Singh to summarize the whole thing and give us guidelines how to go about it. And I have a feeling like I know it, electronics is not required for everybody, which I don't agree. I think we can understand a little bit. The concept, we should, if we know it, only we can control. For example, the decision makers are all, when you buy drones, when I went someplace, when I saw 8 drones they purchased, I could not find one person who can solder it in the place. One electronic person is not there. And there are a lot of professors. There are a lot of professors, agricultural engineers were there, and agronomists, everybody was there, but not a single person to know about how to, if it falls down, what to do, how to open it, what is it. So this is the problem. Actually, we want to address it. Actually, the youngsters are willing to come. And I've seen in several, 2 of the IAC meetings, 3 meetings, whatever it is, I've seen some of them. Youngsters from other area are coming now, electronics area coming, we do this. For example, when you talk about, you want to find what insects are coming in the plants, okay, by just putting on the, I mean, I won't tell all the technical names now. So they come with a different technology talk, but they don't know about agriculture. But we agriculture engineers, we don't understand what is the technology. So I think there's a bridging the gap is what my objective, but I want like to know, you have given excellent suggestions. I think wetland is suggestion one given. We look for all. One more thing I want to say before Dr. Singh concludes, we want good speakers. Like one mention of who is a speaker, Robesh Maity, that's insignificant for me because we are all old enough. We don't actually, but I think I should introduce him who he is. But I think he is a great guy. He works on technology and everywhere he is. That I think next time we make it a point that we'll introduce the speaker properly. This was informal gathering. Actually, we thought we will not give a presentation also. We will have a more interactive, but unfortunately because it's organizing first time, so we had a problem and we will try to correct it next time. And one more, my suggestion before I give it to Dr. Singh is, my suggestion is, so like we have to decide whether 6 to 7 we'll have the speaker and the initial talks, whatever it is, and then training afterwards, because who doesn't want to participate in the training, who are not interested in these talks, what we have, they can come for only few training of electronics and embedded systems. This decision has to be taken today with all of you. Thank you. I will give it to Dr. Gajendra Singh.
Thank you, Syed. Good evening, everyone. I'm calling from New York, so it's morning for me. I'm very excited to hear this webinar. I think this is an excellent start. Dr. Indramani gave a very good broad outline of what is the objective and how we should be doing. And then Syed going into little more details of various topics. The list of topics is excellent. So I think in this first week, we should be basically touching the only the surface, kind of creating interest in these topics. I will suggest that we should avoid in-depth details of these technologies because that might put off people, because idea is to attract more people, create awareness about the importance of these, whether you're talking about electronic components, programming or cloud, whatever you're talking about. Idea is to use this week to emphasize the importance of these things. Now, it'll be up to the individuals to pick up a stream because everybody cannot be expert in all kind of electronics, but I think you can pick up certain sensors which are related to your area of activity. whether it's your research or whether you are in industry or anything. So I think you identify your area of interest and you can go in depth, and they will become the future topics for webinars based on the feedback. So I think first is I like to suggest these presentations, people should make a nice compilation, which will become a kind of a simple book form. The basics we are trying to discuss in this week, which become a ready reference. And I think ISA should take up this job identifying somebody of compiling these discussions and presentations. Next is, I think I like to see that this is an excellent opportunity to bring academics and industry together. See, the all kind of applications we are talking about is the industry which will use these and bring to the farmer, okay? But it's the responsibility of agricultural engineer to great extent to even explain to the farming community how these things work, or make them aware how useful they are, so they pick up those products. And industry then will be very happy that you are opening up or expanding the market for these technologies, which make their systems more efficient, more economic, okay? So I like to see that. Now we have to get a feedback. Now, I think the word term agri-tronics is very attractive. So yeah, thank you very much for bringing this word out, because mechatronics has picked up already, and mechatronics has becoming quite a activity. We cannot take mechatronics. I think they, like PAU has started to even, and there are no takers in agricultural engineering or College of Agriculture Engineering. They had difficulty getting applicant. But agri-tronics is a much broader term. Whether you are using electronics in irrigation field, overall precision agriculture or tractor or any aspect of agriculture. I think this is a good term. I would like to see that, I like the presentation of Robesh Maity, but I think this is a little early for our people to understand all these details. So I think after we have some more understanding of the basics, I think people will be able to pick up. I had asked Mr. Keswan of TAFE to give a lecture on exactly the same thing in Club of Bologna. And actually I picked up for that. And I think probably Robesh knows Keswan very well. So I think the topics we have to be in the first week, really make it like introductory to create interest, but not that basic or not that simple also that people think this is too elementary, okay? So to find a kind of a judgment. Sayyad gets very excited about finding weaknesses. I like to suggest, rather than we look at that way, we look for the potential of these topics to strengthen agricultural engineers. I think that is the motive I see from Syed, Indramani, everybody talking about that, the strengthening the profession. So I think everybody should maintain a very positive tone of supporting it, okay? So I like to stop here, but I like to say that an institute like CIAE Bhopal should really become a center of hosting some of the new experiments and introduction of new technologies, because we need one place, and CIA being the central institute, IRI can also be another place, IIT Kharagpur could be another, PAU or other places, TNEU, but I think the CIA being the central institute, I think should take a lead. I'll stop here, and we have a lot of interesting topics. I hope some of those topics will be picked up for the next series of webinars. based on this 1 week interaction, we should identify the topics for the next series of webinars. Thank you very much. I really enjoyed it thoroughly. Thank you.
Thank you, Dr. Gajendra Singh. I think for the first day, we are almost coming to the closure. I'd like to ask Dr. Indramani, you would like to add something?
No, it was very exciting session, as Professor Singh told, and I'm very happy that Dr. Alagu Sundaram participated, and he has messaged also that he enjoyed it very much, and he is looking for great output from the. He is head of the agricultural engineering family in the nation as a Deputy Director General of Agricultural Engineering. Dr. Mehta was on, he's there, but somehow he is not able to connect. So we will see that what was the problem in next time. We'll see that he should be there. And what Professor Singh said that first week, as we have planned, we will be trying, to basically focus on basic things. And next week will be on application. One more thing I want to add that ISA Executive Council, a few members are here in the group. We would like that we should take feedback from the participants that
Yes.
what they liked and then what they want. So every day, on everyday basis, we can fine tune the program. Ultimately, it's not like that in the end they say that I got this, I like this, I did not like this. So I will be looking for a dynamic feedback and improvement and correction system, so that basically, dear friends, youngsters you have joined this, who all have joined this session, it is for you, So you have to suggest that how to make it more and more impactful and effective. And since we are going to have very great presenter, I'm trying to contact even people from IIT, and then IIT friends have agreed. Sony and then Mishra will be talking, and then from there Kingsley has agreed that someday after 24th. Then we have from NRSA also. So those people will be in the, and then Ganti Murthy has agreed. I have requested, I discussed with you, I have requested him to contact Bora and 1-2 more persons who can participate, because we would like that audience and particularly the participants should get a lot, and so that for next program they should be more insight, insight. We would like even suggest that if some youngsters want to participate, even present some good things, take the input.
Yeah.
Absolutely.
Even he is a young man, youngster. He has started career. He is has expertise in some area. We would like to have him in the project, because we have 10 days, my dear friends, and let us make it a wonderful, very useful event and a useful. And once again,
Dr. Indramani, I like to come here. There are some people who want to ask some questions, I heard. So they can raise their hand. There's an option to raise their hand. And I would like Vijay Patel to come on the line. Please, Setu. Put Vijay Patel.
Yeah.
So he will handle the question and answer. If somebody has few questions, we can take from the audience. We are not well prepared today, but then we can take that step. Vijay, please come online. Can anybody questions ask? You can please coordinate, Vijay. Anybody raises hand, please turn on the video and.
Yeah, if anybody having questions, so please. You can
Hello,
just
sir. Good evening, everybody. It's my great pleasure to be here. I am myself Dr. Pradipta Kumar Sao. I am working as associate professor in Odisha University of Agriculture and Technology. And I am very much interested in this automation in agriculture. And I found Robesh Maity lecture, which is very much similar to my research, what I did in my career during my PhD program in IIT Delhi. I worked on the emission characteristics of different alternate fuels in IIT Delhi in collaboration with ESCOT's R&D Center. So for me, it must be one of the exciting webinar which I am going to attend in my career as a first. So thank you very much for accepting my candidature to the ISI. So nice of you. Thank you, sir.
Any question?
Please ask specific question. Okay, please.
Question and
Doesn't
how
matter.
to.
They can talk anything today, first day.
Yeah.
I think doesn't matter. It's okay.
Sir, we'll be interacting in subsequent classes whenever
Thank you,
you
sir.
will be taking.
Thank you.
Thank you, sir. Thank you, sir. Yes, Bhaskar.
Good evening. I have a specific question for Robesh Maity, sir. First of all, whatever was presented was meant for tractor beyond 50 HP range. Okay, am I audible? Just confirm back.
Yeah, very much. Please go ahead.
Yeah, you are audible.
So, in the e-vehicle scenario, which is very much likely to happen for below 50 HP segment in tractor industry, all these tier 4, 6 improvements would likely be done in the Western world, developed world, and we would be just simply utilizing those understanding of the Western world. But for the below 50 HP tractor range, I see that the e-vehicle would probably concept would be more picking up in the tractor industry as well, and the tier 4, 5 and 6 would not be would be needed for the higher range tractors. So in Indian context, how do you see the scenario to move ahead? This is one question. And later on, after I have a certain opinion, having worked for 10 years in the area of automation.
Yeah, so the tier 6 will come in all the below 50, 50, 25 to 50 also from 2024. 2024 is not far away, And electrical technology in farm, that's my opinion, okay, will take its own time. It's already taking in automotive quite a bit. We know this. So over time, the amount of infrastructure requirements, probably it will take a longer. They may run parallel. It's not even cost effective at this moment of time. So they will probably run parallel. I see somewhere 10 to 15 years of horizon, when they will have. That's my prediction. So doctor, you have to say something?
Oh,
yeah.
I think my opinion, I don't know. I like all the work, but I think scenario will change now, especially after COVID, everything. Small tractors will come. I think already one big company has made small tractors very successful, because I think that is not ideal for India, because even Punjab, we have only 50 acres of land. I mean, the bigger size parcel. So I think we should not have very huge, like 100 horsepower above. It's seldom used, because tillage is a question. I don't want to argue here. Tillage is a real problem. Like many people don't come out of that. So let us leave that topic, because tillage power now is not used. Only arrows they are using. I never seen anybody using motorboat plow, which I studied in 1973. So I think the scenario is changing now. Most of the people use rototiller. So technology in tractors will have this tractor itself will change, because I was listening to last one talk about what will change the automobile industry and tractor industry. Actually, Kesan was talking a couple of days back in another one of the webinars, and Kesan, the whole thing was talking about. There were questions about, and Kesan and somebody else from the automobile industry also talked. I think Mahindra person also talked another webinar. So there I listened that they told whether hydrogen vehicle will come, why it's not promoting. What about the electric vehicles and tractors will come or not? So these are all big topics. But whatever it goes, the objective is, I think we need information from the tractors which is existing. Vijay, please continue next.
Yeah, I think now nobody is raising the hand. I think we can go ahead to the next.
Yeah, I think it's correct time. Yeah, sorry, please.
Yeah, sorry, I'm just interrupting again.
Yeah, sorry. Please go ahead. Please.
So I'll take just 1 minute. I just want to put my opinion regarding having worked in the
I think project for today. We will keep on written some people have to go also for other work.
Okay.
So it is 8 now. So we will close for today. Thank you very much for participation. Thank you, please. and we will reassemble tomorrow at the same time, 6 p.m. And we will communicate the topic and other things, tomorrow.
Okay.
Thank you.
Thank you. Thank you.
Thank you very much.
Thank you.
Okay, to close the close session.
Thank